Dino here with a quick overview of the VerifyJWT policy in Apigee. Here I have an API proxy with a number of different conditional flows. Each one of them has a VerifyJWT policy contained in it with a different combination of configuration. And what I've done is used an assign message policy inside this proxy to just set up some contrived data, some fixed data. So I've got a number of different JWT that are just set in there, a public key, some other public keys, and then some strings that I'll use in a couple of the examples. The first case that I'll show you is just a basic verification of a JWT. Now the VerifyJWT does three things always. It checks that the algorithm in the JWT matches what you've specified in the configuration of the policy. It checks that the signature on the JWT can be verified given the key in the VerifyJWT policy. And it checks that the valid times, the expiry and not before times, if they exist in the JWT, are valid. So that means it's not expired and the not before time has been already reached. So let's have a look at this. We'll start it just from the trace UI. The first case will send in a JWT actually we're using it from that assign message policy, so we're using one of these JWT. And we'll see when I highlight the VerifyJWT policy, I can see all the variables that have been read and assigned by that policy. When there's an equal sign, that means that's a variable that's being set. When there's no equal sign, it's being read. And we can see that this is the JWT that's being referenced by the policy. First thing you'll notice is that the VerifyJWT policy decodes all the content in the JWT and sets context variables corresponding to the claims in both the header and in the payload. So subsequent policies can then refer to those context variables and do different things with them. So if you'd like to look at the issuer, if you'd like to look at the audience or the subject or any other claim that's present in the JWT, you can do that, access it via a context variable. If you want to do your own custom parsing, you can get the full JSON, the decoded JSON of either the payload or of the header, and that's free for you to take advantage of in subsequent policies as well. You can also see that the VerifyJWT policy has read this public key and it's looked at the signature and found that it matched and that the issued at time and the expiry time were okay. So the result of this is that the JWT is valid and we get a 200 response. So let's try some of the other examples. Next thing I want to try, so that's the basic, the first example. Next policy I'll try is verifying with a different public key. So it's a different public key that can be used to verify the signature. And what do we expect to happen there? Well, we expect the signature to be declared not valid. So let's try that. And yes, indeed, we get a 401. I can highlight that transaction, and we'll see all the same decoding is happening. It's the same JWT, but this is a different public key. And what that means is the signature will not be valid according to the policy. And the error that comes back will say, this is an invalid token. Now, it's not possible for the VerifyJWT policy to know, well, this JWT has been signed with a different public key. That's not information that's available to it. It can't tell whether the signature is corrupted or valid with a different key or not present. Regardless, the policy is telling us this JWT is not valid. And that means subsequent steps should not trust any of the claims that have been decoded out of that JWT. So you can still decode it, but you shouldn't trust it because the signature doesn't validate. All right, what's the next case we'll look at? This one attempts to verify the JWT, but it specifies a different algorithm here, the PS256 algorithm, than the algorithm used in the JWT. So we'll have a look at and see what happens there. So if I have to specify the algorithm in the VerifyJWT policy in order for it to operate. And we can see that when the algorithm specified in the policy does not match that used in the JWT, you get an appropriate error message. And again, just as before, this JWT is not valid. So it's should not be trusted, and any of the claims in there should not be It can be decoded, but they should not be relied upon. The algorithm in the JWT is RS-256, and we said we were looking for, the policy configuration said it was looking for PS-256. So the next one will use a different configuration. If you omit the source element, the policy attempts to retrieve the JWT from the authorization header. So let's try that. We can get the JWT from that's this JWT. You can just grab that, and we'll copy it, and I'll go over to my terminal window, and we'll set that into a shell variable. And now what I want to do is invoke that with, let's see, what flow was that? We are on D. So we'll use D. We'll specify the header as authorization, and we need a bearer prefix and the actual JWT that we just set. So we'll invoke that. And you can see, once again, it's been treated as valid. So we'll see that request come in, 1D. And the point here is just to show you that you can pass in the JWT in the authorization header and just omit the source, and the JWT policy automatically receives it from that header. You can also specify a different source and pass it in. That's also possible. But this policy, this 1E, I want to show you a way to verify JWT using a JWKS URI. So I've got a demonstration JWKS service, and I can get a token for that. So that is a JWT token that's just been generated. And I'll, once again, set this into the shell variable. And this time, it's not looking for it in the authorization header, but it's looking for it in a different header, and we won't use a prefix. It'll just be like that, and it's 1E. And what you'll see is, once again, that's been validated. So if I flip back to the trace, you'll see the transaction 1E. It receives the JWT from the inbound request. You can see the payload and so on that's been retrieved. And it's getting the key from the JWKS endpoint that was listed for this service. And that is right, you can see the JWKS right there. So this is a really common way to validate JWT. For issuers, they often publish a JWKS endpoint. And now the VerifyJWT policy can just accept that JWKS URI right in the policy configuration with this syntax. All right, so let's show some other examples. For the next one, we will verify the claims, some of the claims in the JWT. And we'll use the subject element and the audience element with some hard-coded values to verify the claims. So let's do 2A, send that in. And you'll see that's been valid. So that works. 2B is another example where we can do a similar thing, but we can refer to context variables that hold the values of the claims. And that's going to work as well. 2C, it does basically the same thing, but I wanted to show you how it behaves when there is a mismatch. And that's possible to happen whether you use the hard-coded values or a reference. And when there's a mismatch, the signature may be valid, the times may be valid, but the JWT policy also checks the claims that you're specifying, and it's saying, look, that's an invalid claim. The audience claim does not match what we specified in the policy configuration. So we reject that. So that's how you can stipulate claim values. Now the next thing I want to show you is verifying JWT, different JWT. So we'll try 3A. And here again, we're seeing a 401, and the reason for that is the token has expired. So if I take this token and decode it, I would see that the token expired some time ago, and it's about 16,000 seconds ago, or maybe 4 hours and 35 minutes, according to the formatted times here. So when the token expires, when there's an expiry on the token and it has passed, again, the VerifyJWT policy will reject that JWT. So that's normal behavior. Now, there is a way for you to tell the VerifyJWT policy to grant an extra time allowance. So there's some cases where you might want to allow a JWT that's expired less than a minute ago or something like that. It's actually more flexible than that. You can set it up with this kind of notation. This one says the time allowance will be 3,650 days or 10 years. And if I run that same JWT through the policy that's configured to give a 10-year allowance, we should see that it's accepted and it's treated as valid. So even though it nominally expired some time ago, because we gave the time allowance, the VerifyJWT allows it. Okay, a couple more cases I want to show you. One is that we do have a new set of algorithms in the VerifyJWT policy. One is PS256, so we can run that, and we'll see a PS256 JWT be validated. This one has the PS256 algorithm. There's the public key, same one we're using, and yep, sure is valid. And then finally, the ES256 algorithm, which is also new recently in the VerifyJWT policy. So if I select that transaction, we'll see that's an ES256, and for that I need a different kind of public key. It looks similar, but it's smaller. It's a different kind of signature standard, and you can read all about that in the various specifications, the JWA specification. All right, so that's it. That's a whirlwind tour of the VerifyJWT policy and some of the configuration options you can use. I'm going to make this API proxy available for you so that you can try it yourself. And any questions, we'll see you on Apigee Community.